We talked about vectors, but I overlooked something, so let's fill in the gap. We're going to look at what's called parametric equations today. Parametric equations are another way of drawing a graph, but we're not going to use polar r and theta. This is what a parametric equation looks like. You normally write it down by telling the person what the x and y coordinates in terms of another variable are. You know, like t squared plus 1 e to the t minus t. And we call this a parametric equation. And essentially what you do is, imagine t equals 0, t equals 1, t equals 2, and so on. At t equals 0, you can find the x coordinate and you can find the y coordinate. And then at t equals 1, you can find the x coordinate. 1 squared plus 1 is 2. The y coordinate is e take away 1, which I'll just write down like that. When t is 2, the x coordinate is 5, and the y coordinate would be e squared take away 2. And if you plotted them, you'd have something like this. Right, it starts at 1, 0, which is there. And then it would go to 2 e minus 1, which is about here. And then it would go to 5 e squared minus 1, and it might be here. And can you imagine plotting lots and lots of points? Can you see, essentially, wouldn't you get a curve? So this is called the parametric equation of that curve. And you start at typically t equals 0, t equals 1, and t equals 2. That means that you do have what's called an orientation. In other words, a parametric curve, not only is it a curve, but you travel along it. In this case, it's from t equals 0 to t equals 1 to t equals 2. You're traveling in that direction. And part of a parametric curve is to put in that little arrow for its orientation. And so there are only really two things that we're going to deal with in today in this section, and that is how to draw it. And the good thing to tell you is that we're going to use Desmos, so that's going to make your life dead easy because it'll do it for you. So that'll be nice. Bit like, you remember when you had to sketch the parametric, the polar, wasn't it nice that you could do it using software? And then the algebra bit's going to come later today, where how do you convert from parametric, which is this, into what they're calling rectangular coordinates? How do you turn it into things that look like that? Okay, so that's kind of what step 2 is going to be. How does this become whatever it ends up looking like that? And that's going to be done through algebra. That's not going to use Desmos. So if you bear with me for a few moments, I'm going to go in and hopefully share a Desmos screen. Right, are you looking at a Desmos screen, guys? Okay, great. So I'm going to put that in a second. I've got one more page I want to open up. It's this one, and we are good. Right, so if you want to type in a parametric equation, let's suppose x was, what did I have a minute ago? I'll make up my own. Right, let's suppose you had the x equals, don't want a capital, t squared plus 1. And let's say the y fella was e to the power of t take away 2. And here you put in the start value of t, and there's the finish value. And can you see t0, t equals 1, t equals 2? Can you imagine that's what the curve is like, and the direction is from here to here? If you wanted to know for sure what t equals 0 looks like, right? If you plug it into here, you get 1, -1. So if I do 1, -1. And I got a little touch there on my keyboard. Do you see the dot? It's in red. You see that guy? Now, that tells me it starts there. Now, where's t equals 2? I should be able to just go here and plug in the value of the function at 2. 2 squared plus 1 gets me 5. And e squared take away 2 is the other guy. And not a surprise, can you see it's at the end? So if you were doing the orientation, wouldn't it go from red dot to blue dot with a little arrow? Because what is going to happen is in Desmos, you're going to get 4 pictures, but they're all going to have arrows in it. And can you imagine one of them would have an arrow going up the hill, but the other one will have an arrow going down the hill. So if you don't know the orientation, you've got 2 guys, but you're not sure which one is which, right? Do you see how you figure out the orientation? The start number, red dot, the finish position, blue dot. Red to blue is where this one travels, right? Went uphill. Are we good? Right. This one I'm just staring at is question 2. So I've got this set up, so I might as well use it. So you type in 3t, and the y is t plus 1/3 squared. So I'll have to rub this out because that's not going to work. T plus 1/3. I think I got to be careful with the brackets in this world, right? Squared. There we go. Make that guy go away, make that guy go away. I'm just checking if this is a start and finish value. Right, this doesn't have a start and finish value. So what I'm going to do is just pick my own. So t equals 0 is always a start anyway. So 3 nothings plus 1 gives me 1. And nothing plus 1/3 squared gets me a 9th. So, well, I already know. Can you see the green dot? Can you imagine the other dot's going to be there? Isn't this going to be a curve that goes uphill? Now, if I change this not to 2, but say 6, you see, you get to see just more of the curve. A lot more of the curve. There we go. So another thing that parametric equations do that normal equations don't is, can't you have a start and a finish to the curve as well? If, at least if you add that constraint there. Any questions so far? I think Desmos is going to be quite easy to draw them. Here's something you're allowed to do. You can even put negative numbers in. So there your curve, like happy face. Do you notice that this curve was going uphill? So I know what direction it's pointing. I'm now going to put a guy on the screen for you and show you what the homework question would look like. It's very visual. Yeah. Oh, well, I'm looking at where my picture goes. It looks like that one, don't you agree? Based on the numbers. Right. Yeah, looks like that one. Let's see if I can find one more of the drawing of the picture part. So 3 sine t, 3 cosine t. I think I've got enough brackets here. There we go. And we're being asked in this question to do from t equals 0 to t equals pi. And there it is there. Rub this guy out because that's not the one I need now. Right. You see it's half a circle. Now it could start there, right, and curve down the way, or it could start here and curve up the way. You agree? So I'm going to pick t equals 0. 3 sine zeros is 3 nothings, which is nothing. 3 cosine of zeros is 3 times 1, which is 3. And do you see my dot is at the top? Right, so that's where it starts. Now, if it starts there, would you agree it just has to come back home to there? So you would look at the pictures, and one of them would look like the one I just said. And I'm scanning through this one, and yep, the one that they've got looks just like that with an arrow on. Can we call this bit done, or do you want to see another one? Are you comfortable with Desmos can draw a parametric? Last chance, if there's anybody not so sure, I'll do it. Otherwise, I'll call it good. I just noticed one. It's not a biggie. But you have to do, one of the questions you have to do sine squared. Now, I don't know if Desmos is clever, but if you have to do sine squared, it's probably safer to put it inside a bracket like that. Because I'm about to find out if it's clever enough to do it. Because if you do cos squared t, I take it back. Desmos is clever. It knows how to write cos squared and it understands it. That's cool. So you can do that as sine squared now. Well, let's move on to the second piece of the puzzle, the one that we're really going to be spending most of today on. And that is, how do you convert from a parametric equation to a rectangular coordinate one? And if this was dead easy, some of these are going to be dead hard. And I think you can't see anything because I'm not on my white screen yet. So let me do that. But I was saying, look, this I think for most people is easy. Don't you just do Desmos and maybe a start point so you know where it's going? How to convert is not going to be that easy, especially some of the later ones that I'm trying to do. So let's start off with a nice easy one. This is a version of question 1. X is equal to 8t take away 5, and y is equal to 40. And we're being asked to take this equation, parametric, and turn it into x's and y's, essentially. We got a formula with just x's and y's. And in these kind of questions, substitution is the way to go. I'll call this equation 1, and I'll call this equation 2. Very often, one of these two equations can be turned into a t equals relatively easily. So I'm going to use equation 2, just this one. I'm going to divide both sides by 4. And so what I now have is what t is equal to. And then you put t equals 1/4 y into the other equation. So in this case, x is equal to 8t take away 5. X is going to be 8 times 1/4 y take away 5. 8 times 1/4 gets me that guy. And I could make that look slightly prettier. Add 5 to both sides and take away an x from both sides. Would you agree that's quite a nice looking equation? It has x's and y's in it, and that's what you have to do. So your job is to take this guy and turn him into that guy. So that's one of the strategies. Pick one of the two equations and choose whatever you like. I'm picking this one. and rearrange it so t equals something. And whatever that something is, plug it into the other equation. And hey presto, you've got your equation with x's and y's and no more t's, right? They've all gone. If we try this fella, and it doesn't take long before the questions get quite messy. That's the first one. I'll call that equation 1. And here is my second equation. Call that equation 2. Just by looking at those two equations, which one do you think is the candidate for picking? The one that's going to be the easiest to turn into a t equals. Even if it's not great, it's easiest.
Probably x.
I would agree. Would you agree, x? I don't really want to try and solve for t here. So I'm going to take that equation. And as long as you do it to both sides, though, so how about subtract 1 from both sides? And then couldn't I divide both sides by 3? And if you divide both sides by 3, you get that. Are you comfortable with what I've done so far, right? T is equal to 1/3 x take away 3. You then put t equals 1/3 x minus 3 into the other equation. In this case, it's equation 2. So you have y equals t plus 1/3 squared. Y equals, instead of t, replace it with this. Oh, that cancels. And 1/3 x times itself is 1/9 x squared. And we are finished. Do you like the looks of that? Look quite nice. Now, the next question I'm going to do is a variation on a theme. It's similar to what we've done, but there is a slightly different approach to it. And the approach is just to make your life a little bit easier. Normally, the goal is to get a t equals, right? And that will work for this question. If I call this equation 1 and equation 2, would you agree that equation 1 would be the one that I should start with? Would you agree that's going to be the easiest? Okay. And if I did that, wouldn't I get t equals the square root of x? And that works perfectly fine, right? Just like this one. And you'll get the right answer and not a problem. But I have got another suggestion. I'm going to put x equals t squared into y equals t squared plus 3. Would you agree that t to the 4 can be written as t squared squared? Now, won't that mean that y is just x squared plus 3? Wasn't that a little bit quicker? Now, if you don't like that shortcut, just call that t equals the square root of x. You know, 3 or 4 lines later, you'll get the same answer. So it's not a biggie.
Can you explain that again? I don't understand how you got to the answer.
Okay. I'm looking at this guy and I'm saying, oh, wait a minute. T to the power of 4 can be written as t squared squared. Are you happy with that one? Now, why t squared? Well, wait a minute. X is t squared. So that can become an x.
Okay, thank you.
So it was just me saying, hey, I don't need to always make it t equals. Could you imagine there might be some cases where t squared equals x is useful as well, or t squared equals whatever it happens to be. It's just a shortcut that may or may not work for you. Right? If you don't like it because it's just, yeah, I'm not so sure what's going on here, then you might choose just to do it the usual way. How many psychiatrists does it take to change a light bulb? You meant to say, I don't know. How many? Say again?
I don't know.
Only one, but the light bulb has to want to change.
Solid.
Okay, just came into my head. Now it's gone. Right. Nah, nothing there. Here's something a little bit new. You know, trig can't be that far away. This is a different strategy. It isn't helpful for you to try and pick either one of these two equations and to try and write it as t equals. Can you just trust me that if you try to do that, it would be really, really ugly and not very helpful, right? So don't go there. Whenever you see trig equations, you have a different approach. What you want to do is try and do and use trig identities, right? Trig identities, okay? So I'm going to take equation 1 and divide both sides by 3. This is not the only way to do it, but this is what I'm showing you. I'm going to take equation 2 and I'm going to divide both of those by 3 to get that, okay? So far, so good. Now, if I square both sides, won't x squared over 9 be sine squared t? Would you agree? If you square x over 3, you get x squared over 9. If you square sine squared. Now, remember, as long as you do it to both sides, it's all right. It's okay. Now, if I take the second guy, I'm going to get y squared over 9 is equal to cos squared t. And I'm looking for, I'm trying really hard to find a trig identity that I can use. Do you notice that sine squared and cos squared play well together, don't they? Great. So what do you get if you add them?
One.
Now, as long as you do it to both sides, it's okay. So I can add these together. And I'm now going to multiply both sides by 9. There's our answer. Okay. Try another one of these sine cosine combinations. 4 sine t, 2 cosine t. If I divide both sides by 4, I get that. If I divide both sides by 2, I get that. If I square both sides, I get x squared over 16. And if I square that one, you get sine squared. And if I square both sides, I get y squared over 4. And I have a cos squared. And now I can add them together. On the right-hand side, you get 1. And over here, you get x squared over 16 plus y squared over 4. And that's...
Wait, what? Oh, never mind.
We good? By the way, that's a circle radius 3, and that's an ellipse, if you're interested. And actually, I didn't realize that until I did it, but this is a version of question 6. Still in the trig world. I have a cosine t, and I have a cosine of 2t. Well, that's not going to work with this strategy. That's what you do if one of them's sines and the other's cosines, right? You can do this. One of them's a cosine and the other is a cosine of 2t. So this is not going to work. Can anybody remember one of the three cosine of 2t's formulas called the double angle formulas? The cosine of 2t. Can you remember one of them? And the one I want is the one that has cosines in it. It's a case of you've written it down somewhere, I hope. Cosine of 2 theta, 2a, or whatever the letter was used at the time.
2 cosine squared t minus 1.
Correct. Now, if I write it like this, we're basically finished. What's y equal to in terms of x? I'm pointing at it.
Is that
Minimum.
2x squared minus 1?
Yeah. You see, identity, turn it into something that you can use. But trig has so many identities, right? You have to deal with whatever it is that they give you. Here's one. I don't know why I wrote them back to front, but it doesn't matter. Okay. Secant t cosine t. I need to make these two guys play well together. Can you think of another way of writing a secant?
1 over cosine.
Oh, wait a minute. Isn't the answer 1 over x?
So does it not want us solving for both?
Well, what we're doing is we want to tie them together. So all you want is an equation that has nothing but y's and x's in it.
Okay.
And that's what you're being asked to do. Essentially combining the information together in terms of x's and y's rather than in terms of these guys. Right. Moving on to a different question. So I got this one. This is number 9. We got it wrong. Whatever. It's still the same question. Any ideas what this one is? It's actually very, I mean, once I do the answer, hopefully it's very obvious, but think about it before I go in there.
Is it just y is equal to x squared?
Correct? You want to explain to the others how you figured that out?
Well, you can just, x is equal to e to the t, right? And so you just swap the t and the 2, so it's equal to x to the second.
Right, something like that?
Yep.
Yep. What about this one? Not all questions are hard, right? They jump around a little bit. We've kind of done a lot of the hardest ones already.
Would it be x is equal to negative y?
Oh, because of this negative thing here? Yeah, I know where you're going. And I understand what you've done. Any other ideas for what it might be?
I believe it would be y is equal to 1 over x.
So that negative that you were thinking about
Yeah.
really is a negative power. So 1 over 80t, do you say that's now 1 over x? Well, I'm going to give you 3 to try. And if you can do these ones, then I'm comfortable about moving on. Right. So, I keep doing Y first for some reason. It should always be X first. Right? That's the first one. That one's a good challenge for you. There are 3. I'll give you 4 minutes, starting from coming up on it now. Try and get as many of those 3 done as you can. If you don't like one, go to a different one instead. Come back to the one you didn't like later. Last few seconds. Okay, we're going to get to go through the 3 questions. First thing I'm going to tell you is that it is possible to get more than one different looking correct answer. Right? When they get really complicated, you may tackle it a slightly different way. So if you don't get one of these right, and right's probably the wrong word, if you don't get the same as me, doesn't mean that you're not right. It could mean you've just found a different version of the right answer. So it's more about the process that you're using. Now, I hope, as I always do with WebDesign, that it's clever enough to know the different flavors of the answers that could agree. Right, so we got this one here. Equation 1 or 2, which one do you think's the easiest one to find t on its own?
Y.
Right. If you decided, which is how I would do it, you're going to add 1 to both sides, and then you're going to divide everybody by 2. Now, if you did that, and that's how I would do it, you're going to get one answer. If you decided to make this thing the guy, well, you'd square both sides, you'd take away 1 and you'd stick a square root in it, and you can imagine it would look quite different because of that. And I'm going to put this filler then. So that's t equals a half y plus a half. I'm going to put it into this filler. So it's going to be x equals the square root of 1/2 y plus 1/2 squared plus 1. And as much as you would like, perhaps just to say, can't I call that good? The answer is no, you shouldn't. You really want style points, which is try your best to make this as simple as possible. I don't think square roots bring anything to this question. So I'm going to square both sides. I'm now going to FOIL out this thing, which gets me 1/4 y squared plus 1/2 y plus 1/4 and 1. They combine to give me 5/4. And then I would probably subtract an x squared from both sides. And that is one of the possible versions of the right answer. It might not look exactly like yours, but hopefully it looks like in the same ballpark. Yeah, I did kind of things. Right, you're shaking your head there. Do you want to share, Ali, how you did that one?
I don't think I'm getting this, but I don't want to keep everyone. So
Okay.
I'll figure it out later.
Okay, not a problem. Right. You may well have got the right answer. Just because it doesn't look even vaguely like this doesn't mean that it's necessarily wrong. So don't talk yourself out of maybe getting the right answer because of that. Right. Weird. A very easy guy, a very ugly guy. What I would do in this question, I'd say, okay, since this is such a nice thing, wouldn't it be a good idea to turn all of this into nothing but sines? Right? So all of this into sines. So I'm going to focus on sine squared t. And instead of cos squared, I'm going to call it 1 take away sine squared. The whole idea is just to get rid of the t's. Doesn't matter. It doesn't need to be a y equals when you're finished. In fact, it probably won't be. Now, if you do that, then y is sine, so that's y squared. 1 take away y squared. Would you get it's quite a pretty answer? Anybody got a different strategy that they're willing to share? Did anybody tackle that a different way, I guess? None that were willing to share? Okay.
Well,
Yes?
turn the cosine squared t into the 1 minus sine squared t
Yes.
so that you could put the y in?
Yes.
Okay.
That's why I did it that way. Okay. Last one. How are we going to tackle this one? Well, I'm looking at them and I'm saying, okay, they have e to the t's in them. That's good. But that has 2t. That's bad. But I can take equation 2, which is this fella. And I can add 2 to both sides, which gives me that guy. And then I'm going to put e to the t equals y plus 2 into equation 1. Well, equation 1 looks like this guy. But if I think about it, isn't e to the 2t just e to the t squared? It's just looking at something in a different way, right? E to the 2t is e to the t squared. And I already know what e to the t can get replaced by. It can get replaced by this guy. So what I have is y plus 2 squared. And what I'm going to do now is just tidying up. If you FOIL this guy out, you get that. I probably subtract an x from both sides. And there is my answer, with nothing but x's and y's in it. I'll ask you again, did anybody have a different approach to that? Because I'm sure there's more than one way to take this one on.
Should it be plus 5 at the end instead of plus 3?
Yes. Did anybody have another approach to this one?
I put x into y, so I square rooted after subtracting 1.
That works perfectly fine. And so your answer would look something like y equals the square root of x minus 1 take away 2.
Yes.
Right, that's good. These are both the same thing. Would you agree they don't even look vaguely the same? But this and this are identical. As far as math is concerned, if you drew all the points where the x's and y's made 0, and all the points where the x's and y's here, matched, you would end up with the exact same curve. And the reason for that is they started off from here, right? This is a curve. All we're doing is rewriting it in terms of x's and y's. So that was a different approach and equally correct. So Ali, if that one you weren't sure about had maybe a square root in it, right? It could have ended up looking maybe more ugly, but with square roots in it, could well have been right. Okay, I am finished with the parametric section, 8.4. I have some square paper and I can find out where I put it. Ah, here it is. Because I'm going to spend some time, for what's left of today anyway, next 10 minutes, drawing vectors and combinations of vectors. So let's suppose I start at any point I like, and I go 1, 2, 3 along, and 1, 2, 3, 4 up. That I'm going to call the vector U. And the components were 3 in the x direction, 4 in the y direction. So if someone said, draw this vector on square paper, this is what it would look like. Agreed? Now you notice that the direction is upwards. Now, if I asked you to draw what the vector 2u would look like, can't you start anywhere you like? Vectors don't care where you start, right? But if you wanted 2u, wouldn't that be 6, 8? Agreed? Double the x's, double the y's. So I would start here and go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And that guy would be a visual representation to you. What would the vector for instance, like negative u look like? Well, start anywhere you like. Well, I'll do it in green. Say here. And the negative of u wouldn't be 3, 4. It would be negative 3, negative 4. So negative 3 in the x means go to the left 3. Negative 4 means 1, 2, 3, go down 4. And you go that direction and start to finish. Do you see the arrows pointing downwards? And that's what the vector negative u looks like. Are we comfortable with the two vectors? Now, hopefully I've done this right. I think I have, right? Aren't u and v and 2u all parallel to each other, right? And isn't the major difference the direction of the arrow or how long the vector is? Next, we're going to look at adding two vectors together. So let's suppose I have a vector u, which is 1, 4, and I have a vector v, and it's 3, negative 2. Now, I want to add these two vectors together. I'm going to do it as a calculation first and then as a drawing later. So if you want to add u and v together, you just take the first vector and you add the components of the second vector. So you get 1 add 3, which is 4, and 4 add that guy gets you 2. And that's what the vector of u plus v would look like. Right? It would be a vector 4 in the x direction and 2 up in the y. So I'm going to start down here and I'm going to go 1 along and 1, 2, 3, 4 up. And I've now drawn the vector u, start to finish. The vector v then begins here, right? That's like the tail, that's like the nose, right? And we're going to go 1, 2, 3 along and 2 down. So that's what the vector v would look like. And the vector u plus v is that guy. And just to check it out, 1, 2, 3, 4 along, 2 up. Do you see it? It matches exactly what the components said it is. So adding two vectors together is a bit like combining two sides of a three-sided triangle, isn't it? To make the third triangle up. And notice that the direction of u plus v is from the original start to the finish. Any problems with that, or we cool? Good.
Did you start drawing vector v from the end of u?
Yes.
Okay.
Right, we call that nose to tail. That's the name that you'll see in some textbooks. Right. Up, nose to tail, nose to tail. And we're just looking and see what they've got. Question 3 in the homework. It's a little bit different from the typical question. You've got a vector. I better put my axes in. Not that you really need axes for vectors, but sometimes they're helpful. And the x-axis is going here, and the y-axis going here. And I have two vectors. I've got a vector u, which is going this way. And I have a second vector v, which is going something like this. And we are being asked to draw what the vector u plus v would look like. So I would probably start quite low. And the vector u is 1, 2, 3, 4, 5, 6 along, 1, 2, 3, 4, 5 up. So 6 along and 5 up for u. So I'll start here and I'll go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. And there is u. Basically, it's that guy again. And then at that point there, we'll do the vector v. And the vector v is 1, 2, 3 boxes along, and 1, 2, 3, 4, 5, 6, and nobody noticed. That should be negative. So start again. 1, 2, 1, 2, 3. That's good. And then 1, 2, 3, 4, 5, 6, 7, 8. Right. Going in this direction is -6, right? Going in this direction is +3. So left is negative, right is positive. Up is positive, down is negative. Right. From this guy, I'm going to go 1, 2, 3 along, and 1, 2, 3, 4, 5, 6, 7, 8 up. And now I'm drawing the vector v. Now, if you combine these two vectors together, if you add these, you get -3. And if you add these, you get 13. So the vector u plus v should be the third side of this triangle, which is that guy there. And according to the math, it should be 3 to the left and then 13 up. So let's see if that works. 1, 2, 3. Yep. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have nailed it. We have now drawn u plus v.
So I have a question.
Yes.
It says draw u plus v, right? What if
Yes.
it's technically different if you draw v plus u, correct?
That's a good question. The short answer is you end up with the same vector.
Yeah,
you may
it's the
yeah.
same thing, just moved on the graph.
Right. Yeah, I'll try and draw kind of over here, right?
Yeah.
What that would look like. Well, if I'm going to do v first, it would be 3 to the right and 8 up. So I'll start here, right? I'll go 1, 2, 3 to the right, and 1, 2, 3, 4, 5, 6, 7, 8 up. So that is the vector v first. And then when the vector v finishes, I'll do this guy. And this guy says what? 6 to the left and 5 up. 1, 2, 3, 4, 5, 6 to the left. And 1, did I do that right? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I may have done my boxes wrong. 1, 2, 3, that's good. And 1, 2, 3, 4, 5, 6, 7, 8. No, that's good. So check this one. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then 6 along. 1, 2, 3, 4, 5, 6, and then 5 up. 1, 2, 3, 4, 5. Oh, it's just me. Oh. Oops. U plus v, v plus u. Do you see you end up and start at the same two places?
Yeah.
That's kind of interesting, isn't it?
But like on a graph, if we were asked to graph it, which one would be correct?
Well, since they gave it in the order u first and v second, you should have done this one.
Okay.
If they said v plus u, you should have done the second one. But technically, if you did this one by accident, I would still give you the points. Do you think if you picked any u and v and you did what I just did here, would they match up like this? Do you think that would be what would happen? If you went u then v or v then u, wouldn't they always match up? And wouldn't they always make a parallelogram? Aren't these two guys just versions of u? Aren't the two red ones parallel in versions of v? Can you imagine if you take a shape that's got two sets of parallel lines and they're the same length as each other? Aren't they always going to meet up as a parallelogram? Let's do a subtraction. See what visually that might look like. Let's pick a different U and V. Oh, darn it. They don't have time. Okay. Another time, another place. Would you like to put your last name down for attendance purposes? And goodbye until tomorrow. And I'll hang about for any questions. I was so wanting to do a U takeaway V, but just didn't have enough time.
Thank you. Bye.
Bye.
So I actually had a question about the quiz.
Okay, which one?
Let me pull it up real quick. It was, I believe 14 or 15. I'm not sure which one.
I'm going to give you the share feature if you want to show me it.
Okay, just a minute. I'm signing in.
Okay.
All right, can you see that?
Nothing yet. It's just but it. I can see it now. Okay, scroll to whatever it is.
So it was these two. And I'm just not quite sure. I think I did it a different way than they did
Right.
for both of them.
You did get some points. If you look at your score, there was a
Yeah.
lot of points added. So I'm pretty sure that I gave you points for them. The answer that they want, the guy that you've got on the left-hand side, this fella here, he is the same as that guy. But the reason I didn't give you all 6.76 points is there is a kind of style point rule which says you should try and make the answer as pretty as possible. So
This
if you
one?
wanted to take, this is question 15.
15. Okay.
Right, so I'm going to take you through 15 for a minute. Can you give me control back again, or I'll take control? Right. Give me your answer with the square roots in it, and we'll see where we can go from there.
My answer was 2x is equal to the square root of x squared plus y squared.
Okay, so 2x was equal to the square root of x squared plus y squared, right?
Yep.
If you square both sides, you get rid of the square root. So typically we don't like square roots. If you can get rid of them, you should. Now, if you subtract an x squared from both sides, you get that. And if you take the square root of both sides, you get y equals the square root of 3x, the answer that they give.
Okay, so I just hadn't finished it.
Yeah, and you were totally okay with that question. It was it's a bit like you said 3/6 and we wanted a half.
Yeah.
It's like that.
Okay.
Okay. The other one, let's go back to that one for a second. I'm not so sure about the other one, whether it is or isn't exactly.
Yeah, so the
things.
equation was r squared is equal to 7 sine.
No, could you go back to the original? I've gave you permission. I want to see what their answer is and see if I can make your answer look like theirs. Okay, so theirs has one advantage that yours doesn't, and that is that your answer has square roots and theirs doesn't. So they're working on if you can get rid of a square root, you can. God in Himmel, okay. So I'm just writing down what you've got. You've got x squared plus y squared times a square root of x squared plus y squared. And the whole thing is going to equal 14, is it? Yeah, 14xy. I'm a little bit worried about the 14, but that might be okay. We'll find out. Okay, I'll take control back again. Here we go. And get onto the white and see if I can make it up. And advanced, and there we go. A couple of ways to do this. I'm going to start with x squared plus y squared is 14xy over the square root of x squared plus y squared. I'm not saying this is the best way to do it, but it's the way my brain is working right now. I'm
Okay.
going to square both sides, which is a classic way of getting rid of square roots. Okay, so far so good.
Yep.
If I do a little cross multiply thing, I'm going to get x squared plus y squared cubed is 144 x squared y squared. If you FOIL this out, you get x to
How
the
did you
6,
get cubed?
cross multiply.
Oh, okay, I see it now.
So you're going to, an x to the 6, you're going to get 3x to the 4y squared plus 3x squared y to the 4 plus a y to the 6 equals 144 x squared y squared. It looks like your answer is not equivalent to
Okay.
what they had. So you may have picked up an R, or
So
something went wrong somewhere.
what I did is, so since it was r squared is equal to 7 sine, right? 7 sine.
Oh,
of
is
2
that what it
theta.
started off as?
Yeah, it's r squared is
Okay.
equal to 7 sine of 2 theta.
Let me put that in. R squared is 7 sine 2 theta. Did you turn the 2 theta into 2 sine theta cosine theta?
Yes.
That's a
And
good
then
start then.
And then I multiplied each side by r.
Okay, let me pause on that for a minute while I
Mhm.
write that down. We'll take each step as it comes. So the way you started it was exactly the right way. That's going to become 14 then, isn't it? Just to skip a line. Okay, that's good. Now, you can't just multiply it by r. You need to multiply it by r squared. And you need to share out the r's, 1 for each.
Oh, so that must have been where I messed up.
That's where it went. You had an r short.
Okay.
Okay. What? Y, x, and a 14, and x squared plus y squared to the 4, which looks much nicer, doesn't it?
Yeah.
Okay. Anything else?
Nope, that was it.
I'll see you tomorrow then.
All right,
Bye-bye.
thank you.